Welcome to webinar. My name is Tim Dwyer. I'm a chair of the CIBSE ASHRAE Group. The webinar today will be chaired by Ewan Rose and the speaker is Hilary Spicer. Unfortunately, due to technical problems, the first few slides do not have any audio. But after the initial 1.5 minutes, the speakers will continue with the full commentary. I hope it doesn't detract too much from today's webinar. Thanks for joining us.
Nuclei when we come into the autumn and winter months. So viruses, and the reason for that is viruses evaporate faster in low humidity levels, thus creating more droplet nuclei. Also, low humidity allows droplet nuclei to stay airborne longer, as droplets don't absorb water weight, which would cause them to fall to the ground. Thirdly, indoor air currents created by HVAC systems and people movement assure that the droplet nuclei will remain airborne indefinitely. And this allows HVAC systems to remove and redistribute droplet nuclei throughout the building to infect more occupants. In fact, if you look at humid countries, they don't have a flu season. It's only temperate countries that have a flu season. Most people think it's people coming from holiday and spreading in office environments, but the reality is it's actually humidity-led. So here's another source of infection, airborne MRSA. Again, this is the NHS generally. You don't think that infections are spread this way, and this includes MRSA. But the conclusions of this particular study were that MRSA was recirculated amongst patients in the air and in inanimate environments. And it also goes on to say, and I quote, measures should be taken to prevent the spread of airborne MRSA to control nosocomial MRSA infections in hospitals. And again, this is the link out. If you want to go take a look at that when you get the PDF version of this, you're welcome to. So sources of infections, other sources of infections, toilets. This is Professor Mark Wilcox, Leeds University. So he's basically really saying that if you flush the toilet without the lid down, you'll be covered in fecal matter. And on top of that, in addition, toilets are ventilated really incorrectly because they suck particulate out of the toilet to the air vents rather than pushing the particulate into the toilet and vent it out at a low level and away from you. So in essence, you're really showering yourself in fecal matter, and then you're walking out and spreading infections by touch. And he went on to say that many hospitals don't actually have lids, ironically, in an attempt to stop cross-contamination from handling the lid. So, you know, here's a source of infection: toilets. Now, you may not think that, you may think that applies or not, but in actual fact, this is actually how the SARS was spread in our earlier example in the Amoy Gardens apartment complex. As we can see from the right, the index patient, the patient with SARS, marked in red in this side view of the tower, he went to the bathroom, flushed the toilet without the lid down, and the SARS was basically transmitted on the prevailing winds back into other apartments with their windows open and across the apartment complex to other apartments who I presume had the windows open. And as I said, it infected 341 and killed 42 people, just that one instance. And of course, it's generally accepted that norovirus is spread by fecal matter. So you can imagine every year in the UK, the NHS, advise people not to come into hospital because they've got norovirus outbreaks. They have to shut wards down. They have to cancel operations, and they have to actually disinfect the hospital with hydrogen peroxide. Well, we do have a solution in that area as well, using a UV solution. Okay, so other sources of infections: hand dryers versus paper. This was carried out by University of Westminster, and this showed that they tested paper towels versus the Dyson Airblade versus generally warm air dryers, and they measured the bacteria on finger pads and palms, and they found that the Airblade finger pads, as you can see, was 42%, palms plus 15%, and in warm air dryers way more, 194%, 254, and paper towels was less. But obviously if you start exploding particulate into the air, some of that will become droplet nuclei, and again that'll get spread by the ventilation system. So again, this is another source of infection which I'm not sure, I don't think many people really think about, but it actually is was certainly show the results in this particular study. Now we find also there's a source of infections of our HVAC heat exchangers themselves, the cooling coils, and we routinely take petri dish samples of cooling coils that haven't been UVC treated, and this is typical of the fungal pathogens that we find, and also the microorganisms that we find on cooling coils. So even if you've got a fresh air system, or so-called fresh air system, you're still going to have a dirty cooling coil, or a cooling coil that's been, even if it's been cleaned, within days it'll start growing biofilms, and this is typical of what the biofilms on them. So I'm not going to tell you anything you probably don't know already, but we're failing to meet EU air quality standards. That's outdoor air. And in my view, building filtration systems aren't really able to filter all pollutants. I think the vast majority of the work that's been done up to now with filtration systems is about stopping PM10s and 2.5s, and I would say in most commercial buildings that's the kind of filtration that you've got. But I'd just like to remind ourselves of the Polaroid study of the 4,000 employees, and the fact that if they raise the ventilation rate and the amount of so-called fresh air, if it was fresh, how much you would reduce the absentee rate. So we're going to talk a little bit about some of the solutions now. So we've got a UVC. This is the characteristics of UVC. It's basically 185 to 254 nanometers, and it's in the spectrum. It's, guess what? It's it's less than UVA and B, which gives you a nice suntan, and it's just above the X-ray level. It actually emits no light, so the UVC that we produce and most other people produces a blue light just to show that it's actually on. Doesn't mean to say it's actually emitting UVC light. And the characteristics, basically, that it'll actually disable the DNA of any microbial, and it doesn't really matter what the microbial is, but it can't reproduce, and that's really quite important. This is just some of the pathogens that it's been tested against, and we've got a test document of many others. But obviously it's things like influenza, norovirus, virus, MRSA, C. diff that infects a lot of people, and mean it makes a lot of people sick. So Okay, here's some other facts about UV. 40 times less powerful than A or B. It won't pass through glass, but it will pass through some plastics. And it's also non-carcinogenic. Non-carcinogenic. There's no UVC at this ground level at the Earth, but there is UVC, but it just won't penetrate the ozone layer. So this is about passive UVC. Okay, typically this is where we would install our UVC array. On the left, you've got air coming in. It comes through various filters, and eventually the air comes to the cooling coil, which, as we said, grows pathogens on the actual heat exchanger itself. And the ideal place to put the UVGI lighting is actually downstream from the cooling coil, but because it also sterilizes the drain pan. In fact, you can reuse that drain pan water for grey water applications, or you can pump it into a water tower, and because it's cold, you don't have to, the compressor doesn't have to cool the water so much. So there's an energy saving benefit just from irradiating the drain pan water. And in fact, one of the other benefits of the UV at the coil is because it kills the biofilms, it increases the thermal capacity of the coil. And in fact, the vast majority of all the UV that we sell up to now has actually been for energy saving, because it'll save about 10 to 20% of HVAC energy, and it also means you have permanently clean coils, so no maintenance, and it's totally uninvasive. So you normally would put it downstream, but sometimes you have drip eliminators on the downstream, so you can put it upstream. It just takes a little longer to affect the coil's cleanliness, if you like. So, but it works both ways round. It works both ways round. There are other applications for and places we can put the UV. So this is typical of a Petri dish sample of this is a hospital location, but this would be, I would say, 99.9% of all heat exchanger coils in the UK. We would dab with the Petri dish, and this is showing mold pathogens, fungal pathogens, before the UV, and you can see it in operating theatres, in operating theatre and a pharmacy, and after the UV, which is pretty much virtually clean. And so there is proof of the mold removal here. So here's an interesting case study. This is a case study from quite some time ago, Liverpool Veterans Administration Hospital, during an influenza outbreak. And the reason why it's interesting is because a UVC was put in on the ward with 209 patients, and they had a ward of 396 where there was no UVC. The other interesting thing was the influenza that was, it was influenza A. Now there's two sorts of influenza. There's influenza A and B. A is a respiratory illness, and B is a rhinovirus, i.e. B you get in your nose and A you get in your lungs. However, in fact, avian flu and swine flu are respiratory illnesses, so they can only really be transmitted by air and not actually really by touch. And this was confirmed by this study because both groups were isolated from each other, but both groups were attended by the same personnel, and there were no restrictions on visits from the community, so they could go between wards. Doctors, nurses, community workers could actually visit the patients in the UVC ward and the non-UVC ward. And after a period of time, and I can't honestly remember, but I need to take a look at the study again. But after a considerable period of time, about 1 or 2 months, the control group was found to have 19% infections of H2N2, personnel 18%, and the UVC study group only 2%. How could that be? Because if it's spread by touch, which is generally the way that flu is thought to be spread, how can that be? So that brings that into question, I think, to be honest. Here's an interesting one as well. It says air cleansing unit to combat MRSA. And I think Peter Diamond's here, and I know that Camphil sell indoor air cleaners, basically UV with UV in a box with a fan, essentially. Really, you draw the air in, you kill the virus or bacteria, and you eject the air back into the room. This was actually at Northbrook Park Hospital, and it was featured on BBC News website as being this kind of wonder unit. But essentially, really, what actually happened was that they significantly reduced the rate of MRSA in the rooms with UV, and they were quite astounded that they didn't believe that airborne transmission of UV had had such importance in this issue. That was a quote from Dr. Pedder. I think they bought about 30 or 40 units that they could wheel to different isolation rooms, etc., etc. But really, it was a very simple principle. They just moved the air with a fan past the UVC and ejected it back into the air. But according, as I say, to the NHS, there is no evidence of airborne spread. This is, again, another particular instance of UVGI in an HVAC installation, and these are the readings that they took in Greenlawn campus and the Ingham orthopedic centres before UVC, bacteria found in the air, and after. So you go 45.5 to 25.5, and at the Ingham orthopedic ward there was 8.6 down to 0.4, and the bacterial concentrations found on all surfaces, and this was touch and non-touch surfaces, went from 7 point something. The dialog box is actually stopping me seeing it, but you can see it's significantly reduced. And again, you can look at that that study anytime you like. Here's another interesting angle on the UVGI lighting. They put UVGI in the ceiling in orthopedic surgery operating theatre, and they reduced the post-operative infections with no UVGI lighting from 2.2% to with UVGI lighting down to 0.5%, a massive reduction. As you can see, 15 infections of 681 with no UVGI down to 17 infections from 3,390. Again, you may not have heard of ventilated associated pneumonia, but it's a big problem in NHS facilities. It doesn't make the headlines, but it's got a very high mortality rate, and there have been studies carried out as to how much it costs to treat ventilator associated pneumonia, and it is between £6,000 and £22,000 per patient. And that also increases the ICU stay by another 28% as well. And the mortality rate is about 51%. So as you can see, with this particular study, we reduced the VAT by 27%, and the cost justification basically was that we reduced the hospital costs considerably, with a yearly savings of 170,000, and as you can see, the UVC system cost was relatively negligible. This one usually brings a little bit of a laugh, but it was a study in an IVF laboratory. It was a 7-year study, and we increased CPR rates. CPR rate is the clinical pregnancy rate. In other words, we had a greater pregnancy rate of 18.2%, which was a direct correlation to the UVC being activated and inactivated. So there's some studies into what are called passive UV. There's also another kind of UV, which I refer to as active UV, and so it's a UV tube with a quad metallic core, and there is one on the right, PHI. So the one on the left actually is does everything the one on the right does, but it also ionizes the air, and we're getting quite a lot of requests from customers that have got passive or natural ventilation in their buildings, but the consequence of natural ventilation generally is there's no filtration. So how do they filter the air without a filter? And the REMI probe ionizes the air as well as killing viruses and bacteria. So So what they do is they actually mimic the hydroperoxides that exist in the outdoor at probably about the same level. So they're pretty safe to use 24/7. The reason why I talk about this is because in these hospital wards where they get a norovirus outbreak, they have these. They missed the wards, which are uninhabited at the time, with hydroperoxides, which means they still have to shut the ward down. They still have to bring in a machine. They missed the ward. They bring everyone back, but there's obviously from using that. These emit hydroperoxides 24/7 at a safe level, which actually means that where they've been put in, there's been significant reductions in healthcare acquired infections. Here's the other thing is they've also got a machine that's carried out a sneeze test, and they reckon that at 3 foot they can actually get a 99% inactivation of a sneeze virus. So this is sort of like an active nano disinfectant that's floating around in the air and actually lands on surfaces and also disinfects surfaces. Not as well as obviously someone coming on and cleaning surfaces, but this is a 24/7 cleaning, not humans cleaning. So I think this is probably superior in some ways, but it should just be an add-on. So here's some sampling that was done at Kansas State University of the REMI probe. So on the left we've got sample hours from 0 to 24, treated samples and control samples, and the log reduction of the control samples and of the treated samples. So you can see the effect that the MRSA and C. diff testing that was carried out. You can see the effect that actually had. They also put it into this is a PHI probe, which they put into a class 5 clean room facility. In the top chart you've got the air sampling. So if we took let's say sample 6, which is right in the middle, which is the part of the room supplied through HEPA filtration, you can see there's been a 99% improvement of the air samples. And again, in sample 6, it's gone from 4 microbial colonies down to 0. And again, as I say, you can use that as like in a 24/7 scenario. So moving on a little bit, of course you can put UV into any kind of air conditioning. It doesn't have to be a large air conditioning system. It can be a splits, it can be cassettes, it can be just in seated with a fan in like an isolation room. Obviously you can use plug-in units, and there are plenty of manufacturers of plug-in, but this particular one that we're showing at the bottom is using the active UV, so that's emitting hydroperoxides into the occupied space. So Air and RGF and are the main companies that we represent, and they've been around. RGF is there for 20 years, so you can imagine the product lines are pretty mature, and they've got kits that fit into pretty much most types of air conditioning systems. Compliance, well, standards authorities recognise it. It's in the ASHRAE handbook. I think it's chapter 16, or it was chapter 16. And in 2009, when the avian, I think it was avian, no, I think it was maybe swine flu was around, they approved a statement. ASHRAE Board of Directors approved a statement that says airborne infectious diseases are transmitted, can be reduced by using UVC, as well as other methodologies, but obviously we're talking about UVC today. It's mandated by the US government, and you can click this link again. It'll take you to the actual document where they talk about it. But it says emitters and lamps shall be incorporated downstream of all cooling coils and above all drain pans to control airborne and surface microbial growth and transfer. But why? I'm going to ask a question. Why did they basically decide to do this? Why did they decide to specify UV? Well, they found that after 9/11, they actually found, in quotes, a jihadist pamphlet specifically mentioning and targeting enclosed areas and HVAC systems. And it said, and I quote, whether used in conjunction with an aerosol generator or by rudimentary liquid or power diffusion, the high airflow of an HVAC system could disperse chemicals out an enclosed area quickly. Even the Brookings Institute basically said air intakes are a soft terrorist target and filtration is sufficient. In fact, it says, moreover, most buildings lack the type of filters that could clean up contamination. So what did they do? Well, they went to a number of manufacturers, Sterile Air being one of them, this is a schematic of what they did. They had an aerosol generator with bacteria and viruses, sampling before UVGI, obviously the device selection, UVGI lamp, and then biological sampling after. They found that spore-form bacteria were reduced by 96% in a single pass, vegetative bacteria 99.96%, and viruses 99%. And that's what led them to actually specify for US government buildings. Okay, so here's a few case studies, not in much detail, but these are ones that we've actually been involved in. So IKEA, this was actually in Italy. They recorded a 38% absenteeism reduction. H&M Hennes, that was down in Brighton actually, 25% absenteeism reduction. The reason why I put that cassette there is that's where we put the UV. And as you can imagine, the aerosolized influenza through warm air thermals were dragged in through the openings in the cassette, past the UV, and then ejected back into the store. There are hundreds and thousands of these devices in, false ceilings in stores and banks and restaurants, etc., etc. And a 25% reduction is a massive reduction. It's a massive saving as well. So, so how can we calculate the cost of absenteeism? Well, we worked with the Chartered Institute of Personnel Development, and they produced an annual absence management survey from data from, I think, about 2,000 companies across the UK. And we've created a cost of absence calculator. It's usually quite a surprise to most companies how much absenteeism is costing them. And we use that data, and you're welcome to use the cost of absence calculator. But here's the so this is the absence management survey, and you can pick this off the web for free. So this is how we calculated it. This is just a typical, and this isn't. This was a particular customer of ours actually. So we worked out the average salary. Obviously, there's some way more, so on considerably less. But I think in the UK the average salary is about 25,000. So we were pretty conservative. We divided it by the number of working days, and then we came up with a cost per day for absenteeism, which was 121.74, and then we multiplied it by the average absence days per year for that particular industry. That's what you can select inside our cost of absence calculator. And believe it or not, the average in the UK is, I think, 7.7 days. I think the average in London is 6.6, and this particular one was 6.6. So we multiplied the 6.6 days by the amount of people in the building, by the person, which come to £803 per year, and then we multiplied that by the amount of people in the building, which is 900, came to 723,000. Our system cost was something like 12,000. So the return on investment was very, very quick. Not least of which we would save them energy and maintenance and all those other things, but we're talking about absence now. We saved them a huge amount of money on that as well. So come and take a look on that on the website. It's worth using, and it's quite an eye-opener. And yeah, so and if you want a copy of one of the absence surveys, I've got them on the website, and I can send you some links, etc., etc. So here's some locations to consider. We referenced the biosecurity, and I'm talking about the possible transmission or the possible injection of biological agents into buildings' air intakes. I suggest iconic buildings such as the Gherkin, potentially vulnerable to biological attack, others like the Olympic Park. Possibly, in fact, a terrorist attack was thwarted at Westfield Shopping Mall quite recently. So they, being terrorist jihadists, are definitely targeting this type of location. Other buildings where the public gather in numbers, like Heathrow Airport terminals, I would suggest, require this sort of approach. Possibly NHS facilities. In fact, one thing that I've really noticed is there's really no biosecurity in NHS facilities. To be honest, anyone can enter, and there's no disinfection procedures in place. And interestingly, this wouldn't even happen in an abattoir, where you'd be required to wear a full hazmat suit to gain entry. So, possibly in those sort of locations as well. But I think it's a public health issue personally, and with the easy access to biological agents and in fact air intakes are easily accessible as well. In fact, we talked to a large metro underground system. I won't tell you where. It wasn't in the UK, but you could access all of the air intake, all their ventilation plans, all the air intakes quite easily, and they're all at ground level. And to be honest, I think that's not any different in the UK. Here's some other possible applications. In-ceiling UV, could put it in toilets so that it would switch on when there was no one there to disinfect the toilet, etc., etc. This is one we were asked to look at for Heathrow during the Ebola outbreak. So these would have been just like you have your security tunnel, where you, if you've got any items, they will bleep. We'll put UV in our own tunnel, which we would call, I guess, a biogate, which is what we did call it. So anyone coming up the jetway from a foreign country would be subjected to a small level of UV radiation, and that would kill pretty much anything on their clothing. So it will be another layer. So here's a summary of the benefits. So really, all buildings should have biosecurity. Currently, we've got none. One thing I guess in our favour is that we are tried and tested and specified by US government, and in Europe actually, our UV is approved by the MOD and NATO. It's actually on our Royal Naval ships actually. Obviously, a reduction in absenteeism is a big benefit, and I think, as I said, there's a disconnect between facilities departments and HR who own the problem. There's obviously, from reduction in absenteeism, increased productivity. In healthcare environments, there are many benefits and knock-on benefits as well. So obviously, reductions in all infections would be fantastic, but this would also include healthcare-acquired infections. I'm not sure whether you know, but the average bed stay is 3.3 days, but with healthcare-acquired infection, it's 10 days. So you can just imagine if you reduce that, the knock-on is to improve bed throughput, reduce the amount of medicines, etc., and nursing and doctors that are required to treat HCAIs. And in fact, I haven't come up with any studies, but I do know that the PHI, RGF with their PHI technology, they reduced in a couple of hospitals the healthcare-acquired infections by something like 39%. Obviously, there's additional reductions in norovirus outbreaks. As I said, that results in perennial, or annual, I should say, ward shutdowns for deep cleans with operations cancelled, etc., etc. So there are massive productivity gains. And I guess the other thing that you should be at least looked at as part of the armoury against antibiotic resistance, because this breaks the superbug mutation cycle. It stops microbials from actually reproducing. Therefore, it would give the antibiotic community developing new antibiotics a chance to catch up. Right now, they're not catching up, and superbugs can mutate quicker than they can develop antibiotics. So maybe it should be looked at for that as well. So as far as I'm concerned, here's a summary of the issues anyway. Biosecurity, from pandemic security to potential for potential biological threats. As I say, currently we've got nothing in place. obviously we need to, in the first place, acknowledge the airborne route to be able to do that. I guess we also should stop using the term outdoor areas fresh air. People often say these are fresh air systems, but it's not fresh air, is it? Because of what we know is in the air, and hopefully what I've shown you is also in the air, bacteria and viruses. Currently, I don't think the filtration strategy is adequate to deal with all the range of outdoor pollutants and or any sort of covert threats. Hopefully, again, what I've showed you today is that ventilation plays a vital role in the spread of infections, and it's not currently really adequately being dealt with. And I think we should, the whole HVAC community should, ventilation community should put greater emphasis on keeping humans healthier, rather than just staying within legislation, seeing what can actually be done over and above that. Because really, you don't have to specify UV. It's not even on the radar as far as the industry is concerned. So I guess to do in the last I don't know how many minutes was to give you some ideas as to maybe where infections, some sources of infections, how they're spread, and maybe some areas that UVGI could be considered as part of a strategy. So that is it from me. I hope that you found it sort of interesting, maybe thought-provoking. Maybe you disagree with what I've said, but you can ask me as many questions as you like, and hopefully I will be able to answer a few of them. You can email me as well if you want to do that after the event. Any sort of interaction would be great. So that's me done, and thanks for listening to me. And any questions?
Thank you very much, Hilary. I liked your understated comment at the end there that we might have found it a little bit interesting. It was certainly interesting, contentious in places, I would say, very, very interesting. Of course, we would have expected nothing less. I would say it's certainly the first time we've ever had a CIBSE ASHRAE Group presentation that included talk about toilets and jihadis in the same presentation, so, and terrorist threats. So, I mean, I learned a tremendous amount, and so thank you very much for that. I had a lot of questions, but the questions have literally been pouring in. So I'm going to let other people, I'm going to put some of the other questions to you, Hilary, if you don't mind. What we've done is, because we had the technical problems at the beginning, we're overrunning by about 20 minutes. So we'll carry on until about 20 past to get some of these questions in. We've had nearly around about 40 people worldwide tuning in and listening to you, including a special welcome to our great friend Bill Barnfleth, who is a former president of ASHRAE and an expert in this area. And so good evening to you, Bill, in the States, I believe, and to many others around the world. You actually name-checked one of our other attendees, Hilary. That was Peter Diamond, who we all know very well. Yeah. So hello, Peter, a filtration expert. Peter has literally been pounding in the questions. So I'm going to start with Peter's questions, which probably won't come, some of them won't come as a surprise to you, Hilary, I think. So here's a question from Peter to kick off. I have previously been informed that the UVC radiation energy level and exposure time required to kill airborne bioparticles in a moving airstream at normal duct air velocities, e.g. 2.7 meters per second, is so high it makes it prohibitive to be used as an HVAC solution. UVC is fine for close proximity irradiating of static water tanks, but his question is does this make it impractical as a HVAC solution? Yeah.
Well, I'd obviously say it is a practical solution because of where we position it. We don't position it in the ducting. We position it across the airflow in the plenum, which is kind of the central part of the air conditioning system anyway. And the typical airflows it's been tested in is up to 2 meters per second, and it will provide a single kill rate at up to 2 meters per second. And in fact, that's what the EPA testing did, as far as I'm aware. It tested it in normal air conditioning environment. Now, there are two things that actually reduce the effectiveness of UV. Number one is the temperature, and number two is the speed of the airflow. As Peter said, So that's why we put it in that position. In terms of the temperature, the UV is actually from sterile air is designed to work effectively in cold moving airstreams and it's effective from 2 degrees to 70 degrees C. So I hope that sort of answers the question. We don't put it in the ducts, and in fact you will find that some people who've got UV that's put in the ducts put it lengthways and not across the airflow, but in line with the airflow. And I'm not an expert in that sort of UV. I don't really know that much about it. I know about putting it into the HVAC system, but that's why I understand they do. That's why they do it, because the UV probably isn't strong enough to provide a single kill across the airflow, but down the airflow, if you see what I mean, parallel. Does that sort of answer a question as well as I can?
I hope so. I can.
You still there?
Yeah, it's Ewan's here. Can you hear me? It's Ewan here. Yep.
Yeah.
Hello, Hilary. Can you hear me?
Yeah, I can hear you.
Yeah, it's okay. Yes, I hope so. I hope that satisfied Peter. He does have another couple of questions which I'll come back to.
Sure.
I'm just going to check that you may have covered this. Didier Senga Shimanga. Didier, I hope I'm pronouncing your name right, and apologies, I'm sure I'm not. Didier was asking, can I install the UVGI into fresh air supply, the fresh air supply stream to face the challenge of airborne contaminants? He's saying most AC indoor units are not equipped with this, so what type of a UV can we use and face to tackle the transmission of viruses? So he's talking about putting it into the fresh air supply airstream.
Yeah, you could. I mean, yeah. I guess that is what we do. So yeah, into the air supply. I mean, usually after filtration, because you want to filter out all the large, horrible, big, lumpy bits of stuff. And yeah, why not?
Okay.
Yeah, absolutely.
Okay, all right. I hope that answers that, Didier. Spiridon Kostopoulos. Spiridon is a regular attendee of our webinars. He's asking about dust and skin flakes, which you did talk about at one point. How does it tackle dust and skin flakes?
Okay. Well, regular passive UV won't, but active UV will, because it ionizes the air. And if anyone knows anything about ionization, basically you clump, you charge the air particles. They get attracted to each other, and gravity drops them to the ground. Or you can put a grounded collector into the occupied space, and the air, the charged particles of air, will be attracted to the grounded material. I can't remember the actual numbers, but I'm pretty sure that RGF, the people that make the active UV with the ionization capability, say that I think it's 96.7% of particulate with the collector, and about 77% of particulate without. In other words, the particulate drops to the ground, and you don't inhale it. Does that sort of answer your question?
Yeah, that sounds good, Hilary. Thank you. I'm going to hop back to Peter Diamond, because Peter asked a few, and the one the one I was anticipating actually. What pollutants does UVC filter out that filters cannot?
Well, UVC is not a filter, for a start.
Okay.
And filters, as far as I'm aware, and I'm not a filter expert, I know Peter is, but as far as I'm aware, I don't think viruses are filtered out by UVC. Sorry, by filters. The other thing is we concentrate a lot on the air coming in the building through traditional, the air take. But what about people bringing in viruses into the building? And what about the fact that people cough and sneeze and all those other things that cause or shed viruses in the building? There's no filter that's going to stop that, because they basically bypass the filtration system. So, in answer to your question, if you just want to repeat that just for a second, UVC is not a filter. It kills things, okay, and it will ionize particulate. It's not. I believe that there's certainly obviously a place for filters to filter the large particulate, and I think there's a place for UVC, both passive and active, in killing right down to virus level. And incidentally, all these indoor air quality tests, none of them can test for viruses. The very things that cause absenteeism, the very things that the HR department own, the very things that businesses are really interested in, perennially interested in reducing absenteeism. That's why they've got all these health and well-being programs that usually is like putting people, making people cycle to work and putting fruit out and making them stand at desks, but nothing is there about inhaling air that doesn't contain viruses and bacteria. That doesn't seem right to me.
Yeah, no, that's
my own personal opinion.
No, thank you, Hilary. That's a very comprehensive answer, and it does prompt me to issue an invitation to you. Peter Diamond and I are both involved in an initiative, an indoor air quality initiative that's been set up by what is now called the BESA, the Building Engineering Services Association. Used to be the HVCA and BNES, and that's it's a pan-industry organisation, a pan-industry initiative to try and bring together the best expertise on indoor air quality. And I think you should really come and give the group a presentation. So I'd like to.
Yeah, I'll be more.
I'm sure then, and then you could have a proper. There's a lot of people there from BISRIA and manufacturers and from CIBSE and so on, and representatives from the CIBSE ASHRAE Group. So I think it would be very useful to look at this side. We are trying to find, because the difficulty is, what do you measure? How do you present to a building owner that they have a problem? Because it's something they're it's something they haven't been forced to measure before, and they're not sure whether they've got a problem and what the nature of their problem is. But I mean, you're putting a value on this by talking about productivity and absenteeism and ill health. So I think that'd be very valuable to have.
You know what?
So sorry.
Well, you know what? It's really funny because.
Yeah, go ahead.
I've been into some customers and said, okay, I tell you what. I'll have a bet with you. I'll put my UV in, and we should agree how much you'll pay me to reduce your absenteeism by 0.1. What would you pay me to reduce it by 0.1%? And usually that's an argument that I win, because they realise how much absenteeism is costing them, and really how low cost the options are, and that includes filtration and all sorts of other health and well-being devices, if you like, or technologies that you can put into ventilation systems, including UV. And I'd win that bet any day of the week. Well,
that's good. We need to get more people taking you up on it. That's definitely the way forward. Okay. You're clearly happy to put your money where your mouth is, so that's excellent.
Oh yeah, absolutely. Yeah.
Another question from Spiridon. Spiridon was saying, is this solution of yours only cost effective for large applications, e.g. hospitals, large buildings? Would it be feasible for small office space?
No way. No way. The great thing is that it's totally scalable. And in fact, in most older buildings, small offices, you've got splits, you've got cassettes, you've got all sorts of small air conditioning systems, and the cost of you don't need such high power UV. You don't need UV that kills in 2 meters per second airflows, because in a cassette it's way lower than that. So you can get away with a much lower power UV. So it's completely scalable from everything really small into whole hospitals, etc. So I would say it's very cost effective. When we reduced the absenteeism in H&M Hannes, they got their return on investment in about a month, in just a month. Now, I would say most industry, in fact, the vast majority of UV that we've sold has actually been for energy savings. Most return on investment for commercial buildings, they're looking at, or commercial clients, they're looking at 2 years. When we combine the energy savings, maintenance savings, and the health benefits, you're talking about months. So does that sort of answer that question for you?
Yes, thanks, Hilary. Thank you very much. Definitely, that definitely does. I mean, it's a very important point, this scalability, isn't it? So okay. We're about out of time, but we have time for one more question. This is from Stuart Bailey I believe Stuart's in New York. So good evening from London, Stuart. Stuart was asking about naturally ventilated buildings. How would you apply this in a naturally ventilated building?
Right. Okay. Well, interesting enough, we were talking to a world-leading architect, and they are they're total natural ventilation geeks, but then I said, well, okay, so how are you going to stop pollutants entering the building, like PM10s and 2.5s, because it from what I've read, and I'm no natural ventilation expert, but it doesn't seem to be there's any kind of filtration from other pollutants entering the building. So you could say it's PM10s and 2.5s, you could say it's viruses and bacteria. So you either put filtration in there, then there's an energy, let's say, disincentive to do that, or you start talking about ionization technologies. And we also, we're not talking about it today, but we work in conjunction with an organisation from Holland who've developed a very, very interesting ionization technology that they can put into urban environments. But forgetting that for a second, we can put those into airflows in naturally ventilated buildings, and the pressure drop is minimal. And in fact, the power to run the ionization systems is also minimal as well. So the way I describe it is like filters without filters. I know that Peter Diamond won't want me to say that, but and I'm sure it doesn't exactly negate the need for filtration. But in naturally ventilated buildings, I definitely think that there's an argument for ionization and UV put together, as well as filtration, if that helps answer that question.
That's great. Hilary, thank you very, very much. That's fantastic. You've handled a lot of questions there. I'd also like to say that by the wonders of technology, and also by our technical whiz kid, Tim Dwyer, the group chairman, your PDF is already on the CIBSE ASHRAE website, CIBSE ASHRAE Group website, which is at cibseashrae.org. So if you want to see...
Well done, Tim.
Yes, exactly. Well done, Tim, who's about to start skiing, I believe, any minute now. But it's up there. So if you want to look at any of Hilary's slides, they're all there at cibseashrae.org. So thank you for that in a PDF format. Hilary, thank you very much again. As I say, I'd very much like to get you along to address the BESA Indoor Air Quality Group. I think that would be a really good step forward for us, because we're trying to wade our way through lots and lots of data and options and what people should be measuring in buildings. And I think you've taken us into some really interesting areas there. And the biosecurity issue is a new dimension for us. So thank you for that. So that's all I'd like to do now is thank Hilary. Thank you all out there on the web. Numbers are still around about 30 odd, so thank you. Lovely to have you all online with us tonight. This is the latest in our CIBSE ASHRAE Group webinars. Tim mentioned earlier that we will be having our AGM on the 16th of March. So we'd like to invite you all to come online again for that. We'd like to do that virtually as well. There's lots of opportunities to get more actively involved in the group. And Tim has been in the chair for more than 20 years, and I think he's looking for someone else to pick up and run with that baton. So anybody want to be chair of the group, please join us on the 16th of March, or any other positions. So Hilary, thank you very much indeed.
Thank you. Thanks for listening to me. I appreciate that.
No, it was a very interesting presentation. Thank you very much. I personally learned an awful lot, and I'm sure all our listeners did too. So just from me, Ewan Rose, I'm Ewan. I'm the Vice Chair of the CIBSE ASHRAE Group. I'd like to wish you all good night from London, and see you all next time. And don't forget the AGM on the 16th of March. And goodbye, Hilary. Thank you.